So hello everybody, and thank you so much for joining today's deep dive webinar on Kubernetes and Vault. I'm Yannis from Adfinis, and today my colleagues Rob from Adfinis Netherlands and Patrick from HashiCorp will show you how secrets management can be done. We all know it's not the easiest topic, but we hope you get a better practical understanding of secrets management in a Kubernetes cluster afterwards. So as you will see, we've prepared some videos for you to show during the webinar in order to ensure everything works as planned. As you know, with demos, it's not always the easiest. And of course, also that you get the most out of your time. As Marianne has already mentioned, we will send you the recordings of this webinar. We will send you the videos and the slides afterwards, only if you opted in, of course, but I think most of you already have. So if you have any questions during the webinar, please feel free to post them in the chat and we try to answer them accordingly. And I think there will also be a little, like 15 to 30 minutes Q&A time afterwards, where you can also unmute yourself and ask your questions. So I think that's all from my side. And with that, I give over to Rob. Rob?
Hey all. Yeah, thanks for being here. Great to see so many people. My name is Robert de Bok. I work for Adfinis, and we mostly do implementations of Vault or HashiCorp products, and typically on Kubernetes or anywhere else, basically. Yeah, we've prepared a few videos. You'll see them in a moment, and Patrick will run you through the slides. Don't hesitate to ask questions. We can ask you to open the mic if you're in doubt or you don't want to do that. Just type it in the chat, and we'll try to answer it there. Yeah, let's go over this content. I think we're in for an hour or so and a bit of Q&A. So yeah, I'll give my word to Patrick.
All right, thanks, Rob. So good morning, everyone. My name is Patrick. I'm a solutions engineer with HashiCorp, and I'm based in Germany, so supporting all kind of customers here, from the small ones up to the largest enterprise customers. And I'm going to walk you through the basics of Vault, do some level settings, so we are all on the same page in regards to Vault. Then we will have a deeper look into how the integration will look like. And then, as we've heard, there are some videos where Rob will walk you through the actual, let's say, implementation, which you can also follow yourself after today's webinar using our own Learn guides. Right, and with this, just let's get started. Let's kick it off by having a brief look at what are the actual Vault use cases. So basically there are three main buckets, one being secrets management, which simply means storing all kinds of secret, either static ones, or even ask Vault on your behalf to generate dynamic secrets. But ultimately, they are technically stored centrally in a place where it's audited and access is controlled. So it's either static secrets or dynamic secrets. And what dynamic secrets actually mean, we will have a closer look throughout the presentation. Then there's the encryption bucket. So Vault can be your encryption as a service API, so that your individual developers do not need to worry on how to encrypt stuff. Just let your application talk to Vault, drop your stuff that needs to be encrypted over at our API. We will encrypt it for you and feedback the encrypted information so that you can store it wherever you want, for instance, inside the database. So making it easy to leverage encryption basically as a service from a central place, and not each and every team has to reinvent the wheel on how to best implement encryption. And then there's identity-based access, which in a nutshell means that, for instance, I can take my personal identity, typically, let's say through an Active Directory account or any other identity provider, and I can consume identities on any other platforms, on AWS, on Azure, on on-premises platforms, etc. So that I can take an identity that typically exists for human users through identity providers, or as we will see also for the machine side of things, how can machines authenticate against Vault using a machine-based identity? Let's have a quick look at the traditional access model. Let's say there is no Vault in the mix, and you are the client. For the moment, it doesn't really matter if it's you as a human being or you as the machine. You want to access, let's say, a database. And in order to do so, you need credentials in order to retrieve data. You need to authenticate against the database system, prove your identity using those credentials, in order to get access to the data. But actually, where to store those? In code, as environment variables, where actually to best place them? Do you have it as a human being on your, let's say, do you simply remember them all the time? How they are shared across team members? Or have they already been used because they've been shared across their initial scope? Like they were intended for personal use and now all of a sudden it's a team secret, which has been around for like forever. Or is it being used beyond the initial like virtual machine or container, whatever, where it should have been used, but it was quite convenient to reuse and share across the initial scope. And basically how to rotate them at the end of the day, how to revoke them if you find right. They've been used more than they should have been. Maybe there was a breach and you want to revoke access. How do you do that? So there are a lot of, let's say, common questions around secrets management that need to be solved, which is really hard to do in the traditional access model if there's no third system in the mix or in that access path between the client and the actual system you want to access. And this is where basically Vault comes into play. And Vault becomes then a critical component of this access model, where before the client is able to talk to the actual system in order to retrieve the desired data, it needs to go through Vault in order to retrieve the desired secrets. Those secrets, again, can be static, for instance, API tokens, username, password, etc. Or, as we'll see, Vault can dynamically or on the fly generate those secrets for you. So they do not exist until they're actually needed. But what's important to understand is every time a client wants to access the backend system, like a database in this example, the client needs to go through Vault first in order to get the secrets to make the actual call to the database. So let's see how this will look like if my animations are still working. Somehow it seems to be, here we go, broken a little bit. So the client authenticates against Vault, and we will also have some dedicated slides around authentication methods because there are plenty. Because you can imagine it's easier for us humans when we have our personal Active Directory account and we can use our own username and password we remember anyway to authenticate against the system and then retrieve any kind of secrets we're having access to or supposed to have access to. And as a result of a successful authentication, we will get a token back. And this token basically has a policy attached to it. And this policy essentially tells the token or Vault, when this token comes back in order to do something, what's the level of access this token has? What is this token essentially allowed to do inside Vault? Maybe it's just allowed to update values, to retrieve values, create new stuff, dynamically create stuff like maybe a username or password, or even a certificate. So the policy basically defines what that token is allowed to do. And then we take those secrets we just retrieved from Vault using our token we were being given from Vault as a result of a successful authentication. Then we can take those secrets and authenticate against the desired backend system. In our case, it was like a database, could be a virtual machine, it could be an API, and we just retrieve an API token. So whatever the secrets in your case might be. But let's say in a real life example or in a real world, it would be like plenty of different kinds of secrets for all kinds of APIs, machines, etc. So it's typically just rarely the case where it's just one type of secret. And then we actually can retrieve the actual data from, let's say, the backend database. And in addition to that, to the basic ACL policies, which control who's having access to what, we can use Sentinel policies. So on HashiCorp's policy as code framework to layer additional logic or complexity on top, which means we can also set, let's say, certain time slots, certain days, maybe IP ranges, so that you can even safeguard which IP ranges within your environment are even allowed to make calls to Vault in order to retrieve secret. If Vault receives then a, let's say, a request from a silo range which has not been specified within this particular policy, it can block the request. You can make external HTTP calls to get maybe information from a ticketing system, etc., etc. So just keep in mind with Sentinel policies, you can lay additional logic on top of basic ACL policy to have more complexity or more factors. So not just like who's having access to which path within Vault, but also under which circumstances, like where the request is coming from, what time is it, what day is it, etc. And Vault, as I mentioned, supports a plentiful of authentication methods. Some are more suited towards the human being, like Active Directory, GitHub, etc., where we typically, or also Okta with OIDC, where we use our own identity we have within a company or an enterprise typically to authenticate against Vault. But there are more, let's say, nuanced authentication methods for the machines, because it then typically depends on, are we talking about pods in the Kubernetes environment, virtual machines, physical machines, are they running on premises, in the public cloud? So it really depends on where the workload is running and what's the best authentication method suited for the use case. In case of Kubernetes, because today's focus is on Kubernetes, we have built actually an integration into Kubernetes, which means that when a deployment happens on top of a Kubernetes cluster, we can leverage, or actually the deployment can leverage their own service account under which the deployment has been executed, and retrieve the token associated, which is Kubernetes service account, and use this service account token to make the authentication call against Vault. And we will have a couple of slides detailing that in a little bit more detail. But just to highlight the idea of using the identity of something the underlying platform has been giving you, like the service account and the token of the service account, to take on the authentication challenge and not create any like external service account in Active Directory or somewhere. Just use what the platform has been giving you and take this for the authentication. Similar example can be on AWS or on any other cloud, where we take, for instance, the IAM principle that has been associated with, let's say, an EC2 instance, and take the metadata from the EC2 instance and make that authentication against Vault. And Vault every time will be double checking what has been given, like the service account in Kubernetes or the token on AWS, and we will verify that always back with the respective API to make sure it's a valid token. So keep that in mind. So that's one basically key takeaway, that with Vault you can leverage native integrations into Kubernetes, AWS, major cloud providers, and leverage the identities that typically exist there to take on the challenge of authentication of machines. But at the end of the day, authentication is just, let's say, an intermediate step to actually get access to the secret storage. And these are then the storages that either store stuff for you, as the name indicates. So it could be static secrets in the key value store, for instance, or it could be PKI. It could, for instance, also be the encryption as a service use case. So this then would be the transit, we call it transit, for instance, can be used for encryption as a service, or you can leverage Vault to dynamically create secrets for you, because essentially the best secret is the ones that do not exist when they are not needed. So Vault can become your broker of actual secrets. This means when you want to access, let's say, a backend database, like in the example we've seen, you can configure the database secret engine that every time somebody or a machine authenticate against Vault and issues a certain read command, Vault will go out, talk to the backend database, create a new username, create a new password for you, associated with a TTL, so time to live, and feed that back to the user. The user can use the account to do whatever they need to do. And obviously that account will have a limited set of permissions to make sure it's just what they actually need. And Vault will keep an eye on the TTL. And once it's basically expired, Vault will reach out to the database and make sure that the account is basically deleted. So the idea being that the secrets only exist at the time when they are needed, and not just sitting static in the key value store. I need to worry about rotation and stuff like that. Just use the secrets when they're needed. And that's about it. And that's what basically we understand when we talk about dynamic secrets. We've basically picked 3 secret engines, which are typically seen, let's say, in the Kubernetes environment, Obviously, there can be more. It obviously depends on the use case, etc., etc. Just for the sake of time, also, let's say, focus on 3 common secret engines. And the first one being obviously where most customers start with is the key value store, storing static secrets. With the key value store, we basically support 2 different types of key value stores. The first one being what we call version 1 is a very basic key value store. You can basically create any path structure within the key value store. And then, as you can see on the right-hand side, add key value pairs to it. Could be username, password, and the associated value. Could be API token and the associated actual API token, certificates, SSH keys, whatever. So that's basically up to you what you actually store in terms of static secrets. But as the name indicates, they're static. Vault will not handle the rotation, let's say, the rotation for you. So you need to worry about when you want to actually update the value of a given key value pair. Vault will store it for you, will make sure that the access to it is governed, that it's audited and all that stuff that comes with it, but you need to worry about basically the rotation. With version 2 of the key value store, we provide versioning. Depending on your automation and what you're doing with the values, you may have an automation that randomly or on a given schedule changes the value, and things can go wrong, like your automation could break, unforeseen things could happen. So we version it. So in case you update the value and you need to go back to the previous one in order to get access to your system again, we version it for you so you can retrieve the previous values actually from the key value store. That's typically a very basic use case where most customers use it as starting point. They gather stuff they have on top of their mind, maybe sitting in code, maybe sitting in Excel spreadsheets, wherever. They're gathering basically all the static secrets, put it in the key value store, make sure you have the ACL policies in place, make sure the audit logging is in place. And this is, let's say, the first step towards a centralized secrets management. But then the next, let's say, step would be to make more use of dynamic secrets, to have less static stuff sitting around, less stuff to worry about in terms of rotating, etc., and use the brokerage capabilities of Vault. And Vault supports it basically for a whole lot of systems, like all common database systems, AWS, Azure, Active Directory, so it even can cover dynamic secrets in an on-premises world, because typically all on-premises systems somehow support Active Directory, like VMware environments. So you can get the same capabilities also in your on-premises data center. And again, I briefly touched it when talking about the authentication methods, secret engines, apologies, about the secret engines. Essentially, either a machine comes to Vault, let's say using the Kubernetes service account, authenticates itself against Vault, and then retrieves a dynamic secret from Vault in order to talk to a database. So again, Vault will reach out to the database, create the username, create a password, associate the TTL, like in this example, 1 hour. There's also a renewable flag, which means you can technically go beyond the 1 hour, so you can bump it up if you ask Vault to renew it. So you can keep using your dynamic secret for a while until you basically hit the max TTL. Then it's over, then Vault will reach out to the database and for sure delete the account. And this can be used then throughout Kubernetes, virtual machines, physical machines, off-premises, on-premises. That's depending on your use case again, but you do not need to worry about the rotation anymore and can make sure that if the secret doesn't or is not being used actively by a human or a machine, it doesn't exist. Bonus, if you, however, depending on how you use Terraform or other automation tools, and this secret potentially ends up somewhere in a state file, in code, whatsoever, you do not need to worry about if you have set a rather low TTL, because then even if somebody gets access to a state file, to a repository, whatever, or wherever it leaked, the secret doesn't bear any risk anymore because Vault will have reached out already and will have deleted it for you. So keep that in mind when thinking about Vault to make ideally use of dynamic secrets. Let's have a little sip of water. And then obviously one big challenge we're seeing technically with any customer out there is the issuance or the issuing of certificates. Each and every system probably needs certificates either to prove their identity, to make calls in terms of authentication to other systems, etc. So within the enterprise, there's usually like a huge pile of certificates required throughout the environment. And for most customers, it's quite challenging to automate that because typically the CAs that have been in place for quite a while typically lack the automation and APIs so that the consumer, no matter if it's a human being or let's say a machine that needs a certificate for itself, for its own web service that's providing, for instance, it's cumbersome to get through that process and it can take quite a while. And as a result, because it's so cumbersome, often the time, how long the certificate is valid, is quite long. So multiple years, sometimes up to 10 years plus. So by the time the certificate will expire in 10 years down the road, the likelihood that the people who have built that process and built a tool are probably not around anymore. They maybe move to other departments, move to other companies. Then the certificate expires and everybody goes crazy because they need to figure out what they need to get in terms of new certificate, where to get it from, and go through all that process again. So it's not a very pleasant experience in typical enterprises. So there needs to happen more automation. And this is where Vault comes into the play to automate that piece. We can act as a root CA or intermediate CA in case you want to leverage your existing CA, obviously. And then we provide the API and the tooling for your users or machines to talk to Vault, get a certificate on demand, and we also provide the tooling to handle the lifecycle. So if, for instance, Vault Agent is installed on a target system that is using one of the Vault's certificates, that Vault Agent will have an eye on the lifetime of the certificate and see, all right, the certificate is going to expire in a couple of minutes. I'm going to reach out to Vault, do the authentication for you, will ask for a new certificate, will transfer it over to the system where the certificate is being used, replace it, and even reload, restart, whatever is needed to make sure the certificate takes effect. So this can be fully automated, a fully automated experience using native Vault tooling. And now we want to have a closer look at how Vault and Kubernetes actually integrate with another, and how, for instance, Kubernetes pods can leverage the certificates, the static secrets, or dynamic secrets stuff. So how can your pod, your application that's deployed as part of a pod, can get access to those kind of secret engines? To start with, there's probably the question, why not just using Kubernetes secrets? Maybe that's the first question on your mind. So there are a couple of reasons why you shouldn't go just native Kubernetes secrets. The first being that by default, Kubernetes secrets are basically unencrypted and just base 64 encoded strings. So they're not really safe. Once somebody has access to the secret store, they can be retrieved, decoded, and the attacker would have access to the plain secrets actually. There's no proper auditing. There's no rotation or principle of dynamic secrets, like I've just explained. If somebody gets a root access of one of the nodes, there's basically, it's open then, and that attacker could get access to all the secrets stored inside of Kubernetes. When it comes to certificates, it can be quite challenging. It seems appealing to define certificates as part of, let's say, native Kubernetes objects, but you kind of need to worry about how you manage the lifecycle. How do you manage the approval workflow that's required? And do you build your own controller, or do you leverage an external system that can do it all for you? And then all the secrets and role-based access controls, especially the role-based access controls, which can be very cumbersome to implement, are on a cluster level. So you have to do it over and over and over again and keep an eye on all the individual clusters and environments. Whereas with Vault, you have one place to configure, to audit, and to control basically all the secrets in a single place. Vault itself obviously can also run on top of Kubernetes. So that's a choice you as a customer has to make if you want to run Vault in, let's say, physical machine, virtual machine, or using our Helm charts we provide to deploy Vault and all it's needed to spin up a, let's say, production ready enterprise cluster on top of Kubernetes. We provide the proper Helm charts for you to do so if you want to choose also Kubernetes to host the Vault environment itself. And then I've also touched on the Kubernetes authentication when talking about the authentication methods a little bit earlier, but here we have a little graph on the right-hand side, which walks us through the actual process again, which means somebody deploys a pod using service account, and then this service account gets a token from the Kubernetes cluster, and you can take this token basically and make the authentication call against Vault. Vault will take this service account's token and verify it with the Kubernetes API, because otherwise it could be a forged token. So we need to make sure that this is actually a valid token, let's say in a given cluster, in a given namespace. So Vault will check that it's valid for you in the background. And in case it's valid, which we will assume for now, the actual application will get a Vault token as a result. And with the Vault token and associated policy, the application inside the pod can then technically do whatever it needs to do inside of Vault. Get certificates, dynamic secrets, static secrets, create new values inside of Vault, whatever. So, but that's generally the flow how we can leverage the identity-based integration between Vault and Kubernetes. But at the end of the day, even if you have a token, you can basically use that token or that integration as part of your own tooling. You can do the API calls yourself, you can build it all yourself, or you take some shortcuts and use Vault Agent instead. So a Vault Agent is basically a little binary that can run as an init container or as a sidecar container, or in this example, both variants will run at the same, not at the same time, but there will be an init container and there will be a sidecar container along with your pod or with your deployment, actually. But at the end of the day, you want to being able to control what that agent is going to do for you. So generally speaking, the agent will do all the authentication process for you. It will automatically pick up the token from the service account. It will do the authentication call. It will take the token from Vault, store it locally, and then do whatever you tell the agent to do. And in order to make it a little bit more a native experience for Kubernetes people that like to define everything in the YAML specs, you can see an example on the right-hand side that you can control the behavior of that set init or a sidecar container using annotations. So via annotations, we, for instance, can control if we, as HashiCorp Vault, should inject, for instance, this agent for you. So you do not have to modify your actual Kubernetes spec and define init containers and all that kind of stuff. We can inject those live for you, and we will discover that and use mutating webhooks to inject the agent into the deployment. And then down the line, you can basically control the agent, for instance, that it's going to create a temporary file on an in-memory volume inside of your pod, where it will render out the actual secrets stored inside of Vault so that your application can pick it up from there and use it for whatever purpose. So this native integration is basically the path forward because it covers all the options with init containers, sidecar containers, automatically injects agents for you, and you can control all the settings through native YAML annotations inside of your deployment. And with this, Rob has prepared actually.
Yeah, Peter, before we continue, we have a question and a good one also. Peter Baumann, do you want to ask this question here or shall I ask it for you? You can open up your mic.
I can ask the question. Do you hear me?
Yeah,
I can hear.
Okay. Are you supporting the ACME protocol with Vault?
Not today, no.
Okay. Okay. Thank you.
Good question,
Welcome.
Peter. Thanks.
All right, and with this, I will just kick off the video where Rob will walk you through the Kubernetes injection, or Vault agent injection into Kubernetes. And if you have any questions, we will monitor the chat in the meantime and answer them along the way.
And next we can install Vault. We're going to install it in dev mode, development mode. That's not production ready. It's unsealed and connected and it's all perfect, but not production ready. But for this lab, it's good enough. So it should be running in a bit. And let's have a look indeed if it's running. It is, but it takes a while. So let's watch that. Partially ready. Yeah, and that's ready. Perfect. So that's basically the development installation. Here it once again says development mode. Don't do this in production. Both are ready, so we can continue with the next step. So Vault is installed using Helm, and now we can actually connect to it. So let's first connect to the container running Vault. There it is. And we can do all kinds of things. It's running in development mode, so free to unseal, and it has been initialized, so sort of perfect. We're now going to enable a secrets engine, key value store, and where we can store secrets in a bit. You see this path that's being returned here, so you could have multiple secrets engines configured on different paths. Let's write a value in that secrets engine under database and call it config. And in there, there's probably a couple of values, username and password. Little bit too long, this line. Let's try to copy everything, see if it works. And yeah, that's perfect. This is a key value store, so it's a static secret. Nothing special about it. It just stores some kind of a secret value, in this case, probably the username and the password both. We can also get data out of it because we're logged in. It's running in development mode. And you see here that both password and username are now visible. But we don't actually need that password. It needs to end up in that container somehow. So let's do that in a bit. Now that that secret has been stored, we can hook up Vault to Kubernetes for authentication specifically. So maybe you have indeed exited. Otherwise, you need to go into the container again. Sorry, not otherwise. If you have exited, you need to go in again. Otherwise, you're still in that container. And let's enable Kubernetes authentication engine for Vault. That's done. And besides just enabling it, we need to configure it so that Vault knows how to connect to Kubernetes. There it is. More details can be listed here, by the way. Next up is to have a policy, and that role is hooked up to the policy. And as you can see, let's just copy paste and explain in the terminal. As you can see, that policy relates only to internal data, database, config. And whoever gets the policy gets read access, not much more. But it's sufficient, of course, to retrieve some kind of a secret. Next up is a role. Let's copy paste. That's hooked up to that policy. That's done. And that means Vault is now ready. It has a secret and Kubernetes can read stuff there. So that's spot on. See you in a bit. Let's configure a Kubernetes service account and first verify what service accounts we actually have now. There's a couple of minutes old, all very fresh, of course, but we need some more. And for this one, we're going to create a file, copy that part and paste it in. In this case, you need some VI or so knowledge, or you can use cat and EOF. what do they call it? Well, let's copy the name too. It's very long actually. Oh, it's there already. That's perfect. That saves you a lot of time. That's perfect. And now we can apply that file. Copy and paste. So that's created. Let's verify once more. If we have an extra account, yep, we do, called internal app. Very fresh one. So that's also ready and prepared. I think we're ready to launch an application. In this case, let me briefly run through it before we actually apply it. There's an application here, it's all prepared, so we don't have to type a lot. So it's picking up things that are already there. We're going to apply it and see if it's running. And just to make sure there are no specific secrets in there. So that application will also probably not work. And that's the whole intent. We'll get back to that a little later. Let's first have a look if that file exists. Oh. Get that file. Yeah, it already exists, so great. It is exactly, I suppose, like it is, so we can immediately apply it. And that's done. And probably we're going to check status. Yeah, it's all there. Even this application that partially works or so is there. And we can execute here. And in this execution, we're going to list some file. And I'm pretty sure it's not there, but let's just verify that. Indeed, that file is just not there. And we're going to make that in a bit. We're ready to inject a secret into the pod. And what we're going to do is patch the deployment a bit. So that file should already be there. It is. And we're going to add Vault to it basically. So that application runs, probably doesn't work. And now we're going to try to make it work. Ooh, I nearly copied too many lines, just a single line. It's patched. And let's have a look at the status. And it's restarting stuff and so on. So give it a moment. All ready and running. So that looks good. Let's have a look what the logs bring us. Yeah, that looks pretty good. And let's see. Oh, that copied too many lines. I don't think it's an issue. So the bottom part, these two lines are also copied and trying to be executed. That won't work, but the top line, oh sorry, the top line did work, and that's the most important part for now. So what did we actually do? We went into the container and catted a specific file that is mounted on Vault secrets. And as you can see in there, there's a map with a password and a username. That's the password and the username we wrote into Vault. So in the container, we can now access the username and the password. It's a bit ugly still, so probably not ready for the application to pick up, but at least the data is there. So we're going to make it pretty in a bit. So how to make it look better or have the application be able to use it? We'll patch the deployment again. Let's have a look at that file. Here it is, and basically what we're going to do is tell it to make a specific file, but it's based on a template. So it's using this secret, it's writing to a specific file, and the contents is a templated sequence here. So PostgreSQL, : / then the username, : then the password, at Postgres locally /wizard. So that should write that file out into the container when we patch it. So let's do that. That's done. Could take a moment, of course. Terminating, yeah. Let's add watch to it. Oh, everything is already ready, so that's pretty quick. So let's go into the container again and cat that specific file, and it should render out pretty usable basically. So let's see if that indeed worked. Sorry for the clicking. Let's go back to the top. Oh, that's a bit ugly. Let's go back to the top. Here it is. So what we basically did in the container cat vault secrets database -config.txt, and we are returned with a nicely formatted file. No new line, but that should not be an issue. So that rendered out that file using a template. So good to go. We've just patched that deployment a few times. You can of course also initially get that data into a container or a pod. Let's have a look. Cat is a specific file that has annotations and is already set up to look at the right place with the right template and so on. Of course, we can also apply this. So let's try that. So in other words, you don't have to patch. That's created. And probably get the status. Notice they're quite quick, so maybe, no, they're all running. That's good. This was the payroll app or deployment. And once again, if we go in here, we basically end up doing cat vault secrets database config, and we should get that file nicely formatted out. And we do, and here it is. Once again, no new line, but that's not an issue. Happy we have colors, by the way. Yeah? So of course that also works. And here's an interesting one. So these secrets are bound to a service account. In this case, we'll try to deploy some other application that has a different service account. Not internal app, but website. The deployment will work, of course, that command, but it will never be healthy. Let's go over it and probably change it to fix it. Get that file, yep, and it uses the service account website. If we were to deploy this, probably get it deployed anyway. Here it is, but it will never be healthy. Copy. So if I would watch this for, it doesn't really matter how long, this will not be healthy. It's unable to get to Vault. That service account has not been authorized. So yeah, no deployment basically. Yeah, so let's troubleshoot that a bit. Why did it never get into a ready state? So we can investigate in the logs. It's still not ready, of course. And let's read a bit if I can see the error. Authentication error, context, deadline exceeded. Ooh, that's probably a bit too long already. Let's see. If I would have run this command a bit earlier, I probably would have seen that this service account is not authorized. So we need to fix it basically. And for that fix, we need to switch that service account from website to internal app. This file should also be prepared. Get that file, it's there. And if we apply that, it could get into a running state. See if we can catch it. Yeah, it's terminating and starting. So yeah, it's already healthy here. And it's stopping the old deployment. That will probably take a moment, but fine. You see the new one is already there and running, and both pods are ready. And of course we can have a look at that secret once more, just like the others. Let's go. And it placed that secret rendered for the application to pick up. So perfect. So these secrets in Vault are bound to a namespace. And what we're going to do here is create a different namespace to see that that namespace does not have access. So we're going to try to simply deploy just as we did a moment ago, using that internal app role, but that won't work. So we'll run into issues and try to fix it. Let's start by creating a namespace. It's there. And let's switch there. And let's, so there's another, well, it's the same file, I guess. Yeah. Let's apply that. So we have a service account called internal app again in that other namespace. Let's have a look at this file. Probably move it up a bit. And we're trying to deploy, I think, the exact same thing actually, but that should not be possible because we did not authorize this, what is this namespace specifically, to use internal app. So I guess we're gonna run into issues. Let's have a look. So deployment works, but the pods will probably never get healthy. Oh. Yeah, it's still an init. Let's watch that for a brief moment. But this machine, this thing has no access, so yeah, that won't work. Let's try to troubleshoot, see where that comes from. So get the logs. And I think we missed it again. Yeah, let's just read here what should have happened. Error authentication, error making API request. Yeah, this namespace does not have access basically. So let's go into Vault again and modify a few things. We're in Vault now. And what we're going to do is write a new role called offsite app that's mapped to internal app, but for a different namespace. That's successful, of course. So we need to go out now and let's have a look at that file in a bit. Let's get this file. So what's happening here for the deployment, we're using the role offsite app, which is now authenticated, or just a moment ago, and the rest is probably the same. Yeah. Copy, paste, that's done, and the status should now slowly turn healthy. Yeah, so the old stuff is terminating, the new stuff is already running, so should be good. Let's see what we're, have a look here at that file again. And there it is, it's rendered correctly. So now it does have access. We fixed it basically. So that's it for this interactive lab. A few issues there, so sort of yeah, created forced issues. That's really nice to see and how to solve them. So hope that helps you out. And hope to see you next time. And next.
All right. So
yeah, we got a couple of questions. I think all are answered, if I'm correct in the chat. If anyone wants to speak or ask a question now, feel free to open up the mic for a moment and ask a question or so. Otherwise, just drop it in the chat. We'll try to answer it directly, and otherwise discuss it here out in the open.
all right.
Hi, this is this is Ajit. I got a bit confused about after Bess's response. So if I have service account 1 in namespace 1 and service account 2 in namespace 2, then can I add these two in one
policy, sorry, in one role.
You mean that, let's say you have the same name, let's say service account test in namespace, give it a name, namespace 1, and you have just the same service account called test, also same name like in the first one in namespace 2. Is that what's the question is about?
Both actually. I mean, the same service account in two namespaces and two separate service account in two namespaces.
So two separate service accounts in two separate namespaces. And you want to have it in the same role. That's, I mean,
yeah.
Let me rephrase it. I mean, technically multiple combinations possible, but the question is, does it make sense to bundle it all in a single role? Because a single role always means that role is basically where you also attach the policy to it, and the policy that grants access to whatever is inside of Vault. And the question remains, do you want to have multiple combinations so that technically multiple service accounts living in multiple namespaces get the same role and in turn access to, let's say, the same type of secrets? Or do you want to be more fine-grained and say, right, I create multiple roles and say, right, for this particular role, I attach a particular policy which has access only to very sensitive information. This is just relevant for this particular app. Then you would create a single role with just, let's say, a single namespace and a single service account to make sure only this combination has access to this particular set of secrets. So this is always something you need to, let's say, keep in mind if you want to squeeze it all into a single role with multiple combinations definitely being possible, or if you want to be more fine-grained when it comes to making sure only a single service account living in a single namespace gets actually access to a particular set of secrets, and not that like if one service account in namespace 2, let's say gets breached whatsoever, has in turn access to all the secrets because it was a shared role and multiple service accounts would have access using the same role. So that's my personal recommendation, is always to be more fine-grained and use less namespaces and less service accounts per role to have this isolation between deployments.
Good question and good answer. And be aware there's namespaces in Kubernetes and in Vault. So just not mix up the terminology.
Sure,
Go ahead.
All right, then there is Vault and Cert-manager integration. Because another common use case is obviously that your applications running on top want somehow to ingress traffic, so the traffic gets actually to your application. And for that ingress, for instance, you want to have certificates in place. And using Cert-manager plus Vault, we can basically automate that process for you, so that Vault is the issuing CA in the background using the PKI secrets engine. So Vault is actually the one that is really issuing or handing out the certificate. Then you have your regular ingress and all of your Kubernetes configuration. And there's one missing piece in between, which is Cert-manager, which basically does the translation between what you are asking for and what Vault is supposed to issue. So like Cert-manager can be seen as the glue between Vault PKI and, for instance, an ingress that requires a certificate. And the good thing, this can also be all specified within your basic or regular Kubernetes YAML files. And then from there on, Cert-manager will pick it up, translate it into the right calls to make to Vault. Vault will issue it, and then we will feed the certificate back to a Kubernetes secret so that it can be picked up from there for the actual ingress. And I believe Vault also prepared a nice walkthrough around that to give you some more insights around it.
Hi guys, welcome to this self-paced lab about Vault with Kubernetes, where Vault is a certificate manager. This is an interactive lab, so the steps describe what you can do, and you can start the terminal here. That just does not work. So I've prepared separate hosts for that we're going to run the steps on. So those separate hosts, they are prepared. Let me just briefly run you through them. There's this code here, and if you go to github/robertdebok and then search for Ansible Playbook Minikube, you can set them up yourself. Basically, they just install Minikube, Helm, and Kubernetes. So that means we can now log into the machine. And it's this one in this case. And before you start, you should switch to Minikube. And that's it. And now one of the first steps in the lab, you can skip a few because we're not going to run it in this browser terminal, is right around here. So we need to clone some repositories that has some code that we're going to use here as Minikube. Takes a few seconds and you can go into the directory. What I've seen, some of these copy paste buttons do work and some copy a bit too much, the output also. So sometimes you have to select the command and paste that in. Most of the time you can use the copy button. First step is to start Minikube. Minikube is a small Kubernetes environment. It's not production ready, it's just good for demos or labs like these. Minikube start. That will take a couple of seconds because it's going to download stuff. This host lives at DigitalOcean. It's connected quite well, but it's not a super quick machine. So this takes a minute or so. After that, we have all the facilities for Kubernetes, but on a small single machine. So it's good to try and experiment. There it is. So now we can verify that it ran successfully. And if it's all running and configured, you're good to go. So now that Minikube is running, we can add some repository for Helm charts. You can still copy paste everything here. That just adds the repository but doesn't really get anything. So with Helm repo update, we receive all the charts that are in such a repository. And that means we can start Vault using Helm. Let's go. There we are. And if you get the pods, you'll notice that it's not, did we skip a step? No. You'll notice that it's not ready. It is there and it will never be ready. That's until we initialize and unseal Vault. So once again, you can run this over and over again. It will never be ready. We'll get it ready in the next section. So we've installed Vault using Helm. So we can start to configure and use Vault. In this case, we're gonna start Vault with a single key shard. That is not production ready, but it's good for this environment. And we'll save the unseal key and the root key in a file that we're gonna pick up on later. That's it. So we now have initialized the Vault operator init, initialized Vault. And that file just contains probably JSON stuff, cat, this and that, and you'll see the unseal key and the root token. That's what we're going to use for now. Here they demonstrate that you can get the key out or the unseal key. You can also save it, and that's what we're going to do because we need it a little later. There it is, and you can also, of course, echo it. Vault unseal key. I should copy paste more. There it is, same value as this value. When it's initialized, it means that the backend is there. It's encrypted with that key, but it's not unsealed yet. We need to unseal it. Each time you start up a Vault instance, it needs to be unsealed. Typically you do that with 3 people or 5 people or so. In this case, it's a demo. 1 person is good enough. And you see now that it's not sealed anymore. So that's good. And the pod should get ready. As you see, I'm starting to copy paste the commands because by now I think the copy button takes also the outputs, which results in small errors. Not problematic, but ugly. Yeah, so that is ready now. And besides that key, we also need the root token. I don't need to see it, that's fine. I'll just save it immediately. There we go. And now that we have it, we can also log in. And with logging in, we can start to use or configure Vault. That's done now, logged in for eternity. good for us. I'll probably destroy the whole environment in a couple of minutes. So that's it for configuring or initializing and unsealing Vault. So we've just initialized and unsealed Vault, so that means we can start to use it and configure it. And that's what we'll do now. First, let's log in to the container. That's it, and we can start to use it. What we're going to do here is enable a PKI secrets engine. So each secrets engine needs to be enabled and configured. So that's what we're going to do now. And we're going to tune it a bit. And we'll we'll initialize a self-signed CA in this case. Especially here, don't use this button. Copy paste just that command, so it's 3 lines, so that you can start to use it. There it is. We get these certificates. We don't specifically need them by now. Next up, we're going to need to configure the revocation location and the issuing location. There we go. And in this case, we're going to create a role with a policy attached to that role. Just copy paste everything in. Should probably drag it up a bit. I'll clear my screen so it's back on the top. And in this case, let's just write in a file and just as input bring this whole policy in and attach it to the role PKI. That's it. And it says to exit, but we're going to enter it again in a bit, so I don't think you need to exit. You can, but we'll enter it again in a bit. So Vault's just been configured to use Kubernetes for authentication, and now we're going to deploy a certificate manager. Here's the steps. It's a single line actually, and I think once again if you copy the whole part, you probably copy a bit too much, including the output. Let's paste this. Oh yeah, I should have exited. I did. I copied the $sign. Okay. All are created. Great. Next, we can create a namespace. Perfect. And we can add yet another Helm repository. In this case for Jetstack. And we need to update the repository in order to receive the list of charts. And now we can install or deploy this the certificate manager. Here we go. Yeah, that looks good. See some errors passing by, should not be an issue. It'll end up, it's being deployed successfully. Good enough. So now let's have a look at the pods in this specific namespace. And we need to wait a bit. It's probably pulling container images. Yeah, it's getting more and more ready. Give this a minute or so. Maybe I can use watch. Yeah. Watch is a little tool to loop over a command over and over, specifically for these kinds of use cases where you want to know when it's done. It runs every 2 seconds, but it's configurable. There it is. It's ready. Everything's ready. And that's it for the deployment of the Cert-manager. So now that the Cert-manager is configured, we can actually start to create an issuer and generate certificates. So let's first create a service account called issuer. There we go. And let's have a look at what secrets we now have. There should be one extra, a couple of seconds old. There it is, our extra secret. And let's store that value in a variable. We'll use it later on. Let's double check if it's there. And let's copy paste them. Such a great typer. Yeah, that's perfect. Now what we're going to do here is tell Kubernetes to make a Vault issuer. And this is where it relates Vault, here it is, with this secret. So let's pop this in. Here we go. So we now have just a file with one variable that should have been rendered to that value. Yeah, it is. So here's that single value. And now we can start to apply that. Oh, let's bring it to the top. kubectl apply. Perfect. And you can read a bit more information here too, by the way. And finally, we can make a certificate, or at least the file that can be applied to create a certificate using Vault. Here's the file. Is there any variable in here? No, none. So that should be exactly the same. Here it is, and we can start to apply that. Here it is. And that's applied. So Cert-manager has now contacted Vault for that certificate, and that's now configured. And we can probably also describe it, sure. Bring it back to the top. It is quite a long list, but the Cert-manager a couple of seconds ago processed this request. So that's it. That's how you can configure Vault and Kubernetes, or actually Kubernetes, to use Cert-manager, to use Vault, and to issue certificates. Hope that's helpful. See you next time.
All right, so that's it around PKI and certificates. So for the integration part there, there's one more we want to have a look on. Give me a second. Struggle a bit with the embedded videos here. Next one. So that's actually another integration or level of integration which can be used, which is that we can use the storage interface. So it's a fairly, let's say, new way of getting your secrets from Vault into your pod, is using CSI volumes. So it is production ready now, so technically you can use it, but generally speaking, it is somewhat limited in its capabilities in comparison to, for instance, the Vault agent injection. So I believe the most limitations are also documented on our website inside the learn guides and the documentation around the CSI volumes. So what can be done and what not can be done, or can't be done, sorry, as of today using the storage interface. But this can be a good alternative solution. And the idea being that we use the CSI volume and that you can add without any agents in the mix. So it's basically agentless, and that you can use the added CRDs like the secret provider class that is then can be used as part of your Kubernetes YAML files. And that essentially what will happen, that you will have a volume inside of your pod where your desired secrets will live inside. So basically the CSI plugins will take care of talking to Vault, making the authentication, and as a result, retrieve the desired secrets and put it on a shared volume so that your application inside your deployments will have access to it. Again, it's agentless. It's a different way of doing it. So there's no right or wrong about it. If you prefer that method and if your environment would support it, then you can basically go for it. But keep in mind that its capabilities are still somewhat limited in comparison to the agent version, which is kind of lower. Top of the line integration, which gives you, let's say, all the nitty-gritty details and controllables, whereas this is somewhat limited for now. And I believe we have also a very short video for the CSI integration so that they have a brief look at this as well. And here comes Rob one more time to have a brief look at the container level integration, storage.
Hi, and welcome to this walkthrough on mounting Vault secrets through CSI volumes. I've prepared a few things, so let's briefly run over them. So if you would do this yourself, you need a bit more time, but you've seen a few steps a few times already, so let's quickly jump through it. I've created a host with all these things installed and Minikube started and Helm repositories installed and updated. So we're now at the installation of Vault once more, and this time a bit different with the CSI driver enabled. So let's pick up from here and continue on the installation. Here's the machine, it's half prepared. So Vault is now deployed with a couple of extra parameters, as you can see. Let's see if it's already ready. Not yet. Brief moment. Oh yeah, it's ready. That was very brief. And that's up and running. So Vault's now there, and we can continue setting a secret. So let's add some secret. It doesn't matter too much. It's just static secret anyway to Vault. And for that, we're gonna log into the container and write a simple password here. What is it? Secrets db-pass, password equals some super secret value. Let's have a look. There it is. And of course you can also get it, and it should show that super secret value, db secret password. Great. That's a usable secret. It's simple but usable. And now we need to tell Vault to use Kubernetes for authentication. You could have seen that a few times, so let's briefly run over it. Enable the auth engine. And tell Vault how to connect to Kubernetes, like that. And here comes a bit more interesting stuff. A policy that allows read capabilities. And that's called internal app. And now a role that uses that policy. Now we can install the CSI driver, and that's again in another Helm repository. So we need to add a repository and not update. Curious if that works. It works. And we get to see the pods again. And here's the pod we just started. 3 out of 3 are ready and running. And now we're going to tell Kubernetes to make a secret provider class and refer to Vault, basically using Vault in this case. So let's copy paste this part. That's just a file, nothing special. Let's just get it. There's no variables in here, so it should be good to go. Oh, sorry. Yep, that's there. We can apply it. That's it. And let's also have a look at the description. Ooh, that's a long list, of course, but there should be some Vault references here. Here's an address, for example. It's called Vault. Yeah, that's configured. Looks good. And now we can create a pod with that secret mounted. So here's the definition, and the tricky part, or the new part, is here. We're going to use a secret store inline CSI driver, and should look up Vault database. So let's take this part. So now we've got a file, and we can apply that again. That's applied, pod created. So we should have an extra pod, which was web app. Let me double check. Yeah, web app. And it's already running, so it seems to be pretty quick. And if we can now go into the pod and cat /mnt, which typically is a mounted path, secret store db-pass wd, password, we should get that secret value out again. Yeah, there it is. So that's Vault filled in those details, and the pod can now use those. So that's a simple setup. It's not rendered into a template or so, so that's That's a different topic basically, but simple. This is a bit of an experimental driver. It does seem to do the job, so good enough. That's it. Hope to see you next time.
All right, that was it. I believe our last technical demonstration, and one last time struggling with embedded videos. All right, before we open it up for Q&A, questions, and just a couple of details where you can find more about Vault, about us, and all the details. So for those of you who were wondering what Rob were actually using to go through all the very detailed steps to produce those test environments and to test integrations, basically it's all in our Learn platform. So if you go to learn.hashicorp.com/vault, you will find a ton of Learn guides, which you can go through in a self-paced fashion that you will typically using, let's say, Minikube, or technically you can use your existing Kubernetes environment as well, but it will guide you through that process and really walk you through the individual steps required to build those integrations.
Yeah, and there are many Learn paths. So not just for Vault, but anyone. So I really suggest you have a good look. It's a good environment to play and try and learn stuff.
Exactly. And there's even more details on our YouTube channels around integrations and how this all works together and how it can be used. But before we close it out, maybe a couple of details around how you can get in touch with Adfinis.
Yeah, so yeah, if you want to get in contact with us, we're here. Just have a look at the slide. And yeah, we do a lot of Vault deployments and help out customers with their Vault environments. So quite a logical partner to use. You don't have to, of course, there's a lot you can do yourself. But typically, if customers need a bigger environment or a production ready environment, then yeah, we're mostly involved. So, and it's not just me, we have a team of about 70 people. Not all of them are specialized in Vault, but many know the product. So yeah, we should be able to help you out. Thanks.
One thing I forgot, wrong direction. In case there's some of you who maybe just heard of Vault but haven't spun it up for yourself, etc. One thing you can have a look at is start.hashicorp.com, which basically is HashiCorp cloud platform, which allows you to spin up Vault, let's say, with just a couple of clicks. And it also provides you to spin up, let's say, a dev instance, which allows you to spin up a playground and test those integrations, for instance, using our cloud platform. But more importantly is HashiConf. And by coincidence, HashiConf Europe actually starting today. So actually this around noon, I believe, or right afternoon, HashiCorp Europe will kick off, and it's not too late technically because it's just an online event these days. You can still go over to hashiconf.com/Europe and register and have a look for interesting Vault and Kubernetes sessions. But more importantly, we typically also have customers speaking on those events who talk about their experience, how they're using our tooling, etc. So it can definitely be worthwhile if you have the time to check by HashiConf Europe and look for the tracks that you're interested in, especially the ones where our customers are speaking about using our tools. And with this, we are done in terms of broadcasting and opening up now for more questions and Q&A, essentially.
Yeah, I think Dimitri already had a question.
Yeah,
go ahead, Dimitri. You can open up your mic. Let me read the question for Dimitri. Dimitri asks, thanks, of course. Follow-up question regarding the CSI driver. How does it compete with the agent? Are there any benefits, or will there be?
Frankly, for now, as a technical contact, I would rather recommend the agent version of it because it provides all the capabilities. Let's say everything you want to do in terms of templating, for instance, which is something we haven't covered in detail today. What Vault Agent can do for you is templating, which means not just you, let's say, fetching secrets from Vault and putting it into, let's say, a very plain text file. What Vault Agent can also do for you, you can, for instance, take a full Apache, Nginx, whatever config file you have, replace the relevant, let's say, lines or pieces where you want to have actual secrets in it, like connection strings to a database, etc. And Vault, or the Vault Agent, actually will fetch the actual values from the Vault secret store and render out a ready-to-go config file in your, let's say, pod, VM, physical machine, whatsoever. So this templating capability is, I believe, not there yet, for instance, with the CSI driver. So if you want to render out complete, ready-to-use config files, for instance, with stuff that's coming from Vault, that's not possible today. That's typically a good reason to stick to the agent version for now, because a lot of customers would like to use those templating capabilities. So have a look at it. It will definitely be improved down the line as a, let's say, second path to getting secrets from Vault into the Kubernetes world, but most customers currently stick to the agent injection.
Great. And Tobias has another question. Tobias, do you dare to open up the mic? We're only with 50 people or so. Otherwise, I'll ask the question.
Between us. So.
Tobias asks, are there recommendations automatically unsealing Vault in production on-premise environments? Yeah, what we typically see is indeed in a cloud environment where you use the KMS to unseal, but that's not available on your on-premise environment. So there's two options there. Correct me if I'm wrong, Patrick. One is to have another Vault unseal your production Vault, but that just shifts the problem a bit because you still have that initial Vault that needs to be unsealed somehow. It is a bit of a solution, but halfway. And you can also unseal with an HSM, but that's not cheap. So I'm not sure if any company just has an HSM laying around, hardware security module, but it's an option. And then Rajasilan, scaling Vault. What are your recommendations or rules of thumb? There is a good article, so let me paste that in the chat. And meanwhile, Patrick, can you read out Michael's question?
I'm just checking where you are in the chat. So just
near the bottom.
For the right, near the bottom, near the bottom. Maybe. See, question from Misha around persisting data. Okay, let's see. Michael's. You mean Michael Schneider's question, right?
Correct. Yeah.
Okay. Now I got it. So there's one more question. How does Vault persist its data if it runs in multiple pods? So that's actually a fair question. And Vault comes since, I believe, version 1.3. Don't let me lie. I believe it was 1.3 with an integrated storage. So each of the Vault servers include its own backend storage, and it's replicated between the nodes that make up the Vault cluster. So it comes with integrated storage, and that storage backend will make sure it's integrated, persisted and replicated across multiple nodes. So that's being taken care of in the backend for you. So you do not need to worry about, let's say, an external backend like console, which was the backend of choice in the past. That's not something you need to worry about anymore. Vault now comes with integrated storage and integrated replication as a result of that.
Yeah, that's correct. And Michael asks, so changes are propagated to all nodes before they're live? Correct.
To majority of the nodes. So let's assume, irrespective if it's like in a Kubernetes environment or physical machines or virtual machines, Vault works off the quorum technology, which means if you have like 5 nodes and 3 need to, let's say, agree to the changes, And once everybody has, or the majority or the quorum has agreed to changes, it will replicate to all the participating nodes. So eventually all will have a copy of the data, but it's considered successfully persisted once the quorum has agreed and has written it to its backend. But eventually all the nodes that participate in replication traffic will have a copy. And I believe there's also good documentation around that. Let me pull it up and I will link it in the chat. Raw draft storage. I can't. This is it.
Patrick just pasted the link to Raft's configuration. Good. Great questions, by the way. Spot on. So good to get some feedback.